Good morning, students. In the previous class, we discussed about the nomenclature of the ketones, and we are discussed, and along with we are discussed about the general method of preparation of, that is aldehydes, that is by the oxidation method. We are discussed in the previous class. In this class, we are going to be discussing about the preparation of aldehyde by ozonolysis of alkenes. Means the alkenes is going to be reacts with the ozone. It's going to be formed, say, that is a cyclic ozonide. It's going to be formed a cyclic ozonide. This further hydrolysis, it is going to be used that is either aldehyde or ketone. When this is going to be treated with, this is going to be cyclic ozonide undergoes the hydrolysis in the presence of zinc, because the zinc is going to be added during the hydrolysis, because when the hydrolysis of the cyclic ozonide, at that time what happens, is going to be formation of the hydrogen peroxide. This hydrogen peroxide easily under good oxidizing agent. Therefore, the formed carbonyl compounds like aldehyde or ketone, it gets converted into carboxylic acid. To prevent this, we are going to be using the zinc. That is alkenes. That is ozonolysis of the alkenes. If you are going to be taken the example, that is ethene. Ethene is treated with the ozone. Ethene is treated with the ozone. This is the ethene. Ethene is treated with the ozone. It's going to be formed the cyclic ozonide. It's going to be formed with, that is a cyclic ozonide. It is a cyclic ozonide. This we call as a cyclic ozonide. This on hydrolysis. In the presence of zinc, that is removal of the hydrogen peroxide. It's going to be used that is respective aldehydes. We are going to get. This is the one of the method of the preparation of general method of the preparation of the aldehydes. Means that is alkene is treated with the ozone. It is going to be used the cyclic ozonide. This on hydrolysis in the presence of zinc. Otherwise, what happens? This hydrogen peroxide formed in this is going to be reacts with the carbonyl compounds. This gives the carboxylic acid to prevent the further oxidation. That is, zinc is going to be used. The zinc is going to be reacts with the hydrogen peroxide. It's going to be used the zinc oxide and the water. That is the reaction which undergo in this reaction. Then next we will take another example. That is the CH3 double bond CH2. This reacts with the, what is the name of this compound? That is 2-methyl. If you are going to be taken as a 1, 2, 3, second carbon contains the methyl group. 2-methyl, that is propene. 2-methyl propene. Thus reacts with the ozone. It's going to be formed a cyclic ozonide. This undergoes the hydrolysis. It's going to be used the ketone propanol. It's going to be used the propanol plus formaldehyde. It's going to be used the propanol and the formaldehyde. It's going to be get. This about that is in the presence of zinc and H2. This is the removal of the hydrogen peroxide. This is about the preparation of aldehydes. And ketones by the ozonolysis of the alkenes. This is one of the method we are going to use to preparation of the aldehydes and the ketones. The next method we are going to be discussing about that is the catalyzation of the alcohols. We are going to be discussing about the next method is by catalytic dehydrogenation. Means the aldehydes are obtained by the vapors of primary alcohols. Vapors of primary alcohol passes through overheated copper at the 573 Kelvin. 573 Kelvin, or you can say that 300 degrees Celsius. It's going to be used the aldehydes. Means the general representation for the aldehydes we can be written as the primary alcohols. That is the aldehydes obtained from the primary alcohols. The primary alcohols we can be written as that is RCH2OH. This is going to be passing through the vapors of primary alcohol. Vapors of primary alcohol passes through the copper, red heated copper at 573 Kelvin. At 573 Kelvin, at that time it's going to be obtained that is the aldehydes. We are going to be obtaining the aldehyde with the liberation of hydrogen. This is the method of preparation of the aldehyde by using the alcohols by the catalytic dehydrogenation. Means dehydrogenation is nothing but removal of hydrogen. Like that we will take example for this. If you are going to be taken this example, CH3 CH2OH. What is the name of this compound? The name of this compound is ethanol. Ethanol is the vapors of ethanol passes through the overheated copper at the 573 Kelvin. At 573 Kelvin, we are going to be get that is CH3CHO with the liberation of hydrogen. The name of this compound is ethanol. Alcohol. The aldehydes are obtained with the alcohols by the method of catalytic dehydrogenation. Means dehydrogenation means the removal of hydrogen. Like this, only ketones also obtained by the passing the secondary alcohols. That is vapors of secondary alcohols passing through the copper. That is copper at the 573 Kelvin. We will take that example for secondary. That is if you are going to take the R, that is CH, then R dash, then OH. This is a secondary alcohol, general representation of the secondary alcohol. These vapors of the secondary alcohol passes through the copper, overheated copper at the 573 Kelvin. 573 Kelvin ಬಂದು example ನಿಮಗೆ ಬೇಕಾದ್ರೆ 300 degree Celsius ಅಂತ ಕೊಡಬಹುದು. Is nothing but 573 Kelvin. Then it's going to be used that ketone. It's going to be used the ketone with the liberation of hydrogen. Example. ಇದಕ್ಕೆ ಒಂದು example ತಗೋಣ. Example ತಗೊಂಡಾಗ then CH3 CHOH CH to propanol. The name of this compound is 2-propanol. This on passing through the red hot copper at 573 Kelvin, we are going to be get that ketone. The name of this compound is that is the propanol. The name of this compound is propanol. That is this about the preparation of aldehydes, ketones by the catalytic dehydrogenation. Catalytic ಅಂದ್ರೆ catalyst ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಕಾಪರ್ ನ. ಇಲ್ಲಿ dehydrogenation ಅಂದ್ರೆ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಅದಕ್ಕೋಸ್ಕರ ಈ ಮೆಥಡ್ ನಾವು catalytic dehydrogenation ಅಂತ ಕರಿತೀವಿ. catalytic dehydrogenation. Next, we are going to be preparing the aldehydes and ketones by alkynes also, from alkynes. Next, we are going to be discussing about it from alkynes. Next method is from alkynes. Thus, alkynes, when the alkynes are hydrated in the presence of, that is dilute sulfuric acid. In the presence of dilute sulfuric acid and mercuric sulfate. Dilute sulfuric acid and mercuric sulfate. It's going to be use the carbonyl compounds. Carbonyl compounds means either aldehydes or ketones. These are hydrated. Means the alkynes. Example, we'll take the alkynes. That is ethyne. The ethane. Example for ethane is, alkynes is ethane. We are going to be taken the ethane. These are hydrated. Means treated with the water in the presence of dilute sulfuric acid. In the presence of dilute sulfuric acid and the mercuric sulfate. It's going to be use the carbonyl compound. That is, it's going to be get that is intermediate compound. This undergoes the isomerization. It's going to be formed that is aldehyde. It's going to be formed as the aldehyde. CH3 CHO. It's going to be CH3 CHO. This aldehyde is going to be formed. That is this about the preparation of the carbonyl compounds. This that is next method is this method. In this method only the preparation of that is ketone. How we are going to be preparing the ketone? We are going to be discussing now. That is next. That is propine. Next example, we will take the propine. That is CH3 C triple bond, then CH. The name of this compound we called as a propine. This propine is hydrated in the presence of dilute H2SO4 and mercuric sulfate. At that time, it's going to be formed that is the CH3 COH, then double bond, then CH2. This undergoes the isomerization. This undergoes the isomerization. It's going to be form a ketone. This is about the another general method of preparation of the aldehydes and the ketones. Then next class we will discuss about the special methods of preparation of aldehydes and ketones. It is very important. The special methods of preparation of aldehydes and ketones. It will ask so many times in the examination. The repeated questions in the examination.